Hi. I'm going to provide some perspective on the STEM movement and the fact that it's based on the complexity of the real world. Although we need to isolate things to really study deeply, in these multidisciplinary environments, we can use problem solving, we can use inquiry and projects to create rich environments. You'll see that in a number of the scenarios that you'll have within the MALIT program, there are rich ways that we show you how you can bring in STEM projects. This was using a virtual environment to study some of the hydrology, some of the environmental issues in the Middle East, looking around the concept of well digging. But the real world problems have really been quite well articulated if you look at what's been done in the K-12 world. It's not that everything is K-12, but it's simply that they have been involved for quite some time in studying these environments. Back from the 1996 area, the first science education standards came out. Then more work was done to look at the engineering design, and additional efforts came out with scientists to look at how the environment can foster thinking, and the next generation science standards has come out now to really articulate and provide examples of how we can operationalize this interdisciplinary approach. Now, we want to keep in mind, though, that the interdisciplinary approach isn't simply about science, technology, engineering, and math. The most recent effort has been to bring the arts in, finding that if you bring the arts in, you can provide a rich environment that often gets that creative, outside-the-box thinking involved as well. So you're going to see that when you can bring the arts into a STEM project, as you will find in some of these background areas, you can bring in a new dimension and encourage some creativity and problem solving that might not have been evident other ways. Now, in the MALIT program, students have already designed a number of areas where they've been bringing arts into their work, and I'll show you some more of those shortly. The government, in the meantime, though, has been providing this vision where we really want to have these interdisciplinary approaches. You can see that grants are becoming available. Plenty of different educators are jumping on, trying to get schools and institutions to involve kids at young ages in these STEM efforts. As you can see down here in the bottom right, it is important that the jobs of tomorrow are being filled with students from today who really understand what's going on. So we need a workforce that can involve students and future workers in this kind of creative problem solving. As you learn in the courses, there are educational frameworks that come in and support what's happening. People learn when they construct their own meaning. So that's a primary principle when you actually have people exploring projects. This theory of constructivism has been difficult to implement. It's much easier to simply just give classic notes. But given the time spent in developing these projects, students will learn more. And you have seen how problem-based learning really encourages that deeper cognition. Also, some of the latest pundits are really pointing out how we now have digital thinkers. The generations and people, say from 35 and younger, have really grown up with these tools. And you'll find, too, that the government and educators are really looking for opportunities where the higher education reaches back to K-12 and tries to provide opportunities for pathways among them both. But let's see what's been done in some of the MALIT courses, looking in light of what the ESC certification requires, and that's the International Society for Technology and Education. One of the things that I've been doing over the years is assembling a lot of resources, which you'll see here. I have developed what I call curated lists, where you'll be finding that there are many materials that others have developed that are now available to you. You'll have websites, such as the one that I've created here, that have many resources that I've been assembling over time. I've also developed websites that actually are aggregating some of the applications that have been developed by students. And you'll find that these can help you look at ways to bring virtual, augmented realities, camera work, and the like into classes. Now, I've also shown several role-playing activities that can be done. But let's take a look at what some of the students have actually done over the years. And we've had people developing anything from citizen science projects. We've had a navigation maritime project. We've had somebody developed a small tiny home project in an English class and brought that into the STEM area. Major cities were studied through 3D printers, where students actually made prints of different key buildings. We've had recipes being shared through mathematics, and we've had a microscope project that can now have these microscopes fit onto your cell phone. Also, students have made makerspace projects. There was a Canadian museum one where the children coming into the museum actually tinkered and created a lot of resources. We've had a healthcare application using augmented reality. 360 cameras were used to help migrants coming into Ithaca and have them kind of get situated. We've had Google Maps. We've even had virtual reality used in corporate settings. So here are a few of these pictures that were submitted during the work of the students. Here's the Canadian Museum. Here's a coding project that was done in high school. Here's the student who used Google Maps to show different parts of towns. We've had 360 cameras being brought into operating rooms to provide opportunities for technicians to see these rooms in advance of going into the clinical setting. Here's actually some pictures from the 360 cameras that were used in the docking simulation. Another student used virtual reality to bring people together in her corporate environment that she owns. She has a small business. We've had English students. This particular student was working in Japan to teach people how to use the slow motion animation as a way of learning how to create complex projects. And we've had robotics. Of course, we've had the Lego kits. We've had environments where data probes were used in physics experiments. We've had, here's a different physics class where they were using coding, using Python as a programming language. And here is actually some more pictures from the augmented reality application, where the augmented reality was prototyped to work with clinical mannequins. And even a third grade project where students created 3D cities and looked at ways to prevent disasters in these cities. And coding can be taught, particularly through some of the MIT projects, all the way down to first and second grade, where they start looking at the concepts of variables. And this one was a very interesting one where the librarian had students creating cultures around main cities and buildings of historic significance. This, again, was the insurance person who was developing a setting for training where people came in from different parts of the state and didn't have to travel. And we had a very interesting ocean pollution cleanup, which was actually provided through kits that came from Legos. So there are many ways today that we can work. There are even places where virtual reality settings are being used for what we call co-working spaces. So there's many ways that within the Mallet program, within your own work, you can create these projects that bring together multiple dimensions and that provide opportunities for the Empire State College partners to work with other systems and people. So, thank you.